All right, this is Mr. Gillum, and what I want to do today is I just want to show you how to label a vector and how to identify one. And we're just going to do a little intro here, and in class we're going to practice some of the stuff we're learning in this video. Let's just take a look here. When you name a vector, there's 2 points. There's the initial point and the terminal point. The initial point is considered to be where it begins, and the terminal point is where it ends. All right, and it's hard to see on this diagram, but that vector, is labeled like so. Okay. It's like almost an arrow without the bottom arrow part on it. Okay, it's called a vector. All right, and so now remember, a vector only needs a distance and a direction, or a direction and a distance. So it doesn't matter where the vector's at on the paper as long as it's got the same distance and same direction. All right, so this specific vector could be labeled vector v, like as it is, or you could label it as EF with the vector sign. Now this is important. The E must come first because it's initial, it's the initial point. The F must come second, initial, because it is the terminal point. All right, so these are just things you need to know when we're labeling vectors, and when you see that sign above the EF, I want it to throw you off. It's not a segment, it's not a line, it's a vector, okay? And it's got that little symbol with it's like a line, but it doesn't have the little, if it was like an arrow, it'd be like that, but we're just going up with it like that. It's a little vector sign, okay? So always the initial point, then the terminal point. All right, now component form. That's a funny name, component form. What we're going to do is we're going to kind of label the vectors almost like an ordered pair. All right, almost like an ordered pair. It's kind of like the X and the Y, where the X moves left and right and the Y moves up and down. But we're going to call it AB in component form. And basically what that says is A represents how much horizontal change is happening, and B represents how much vertical change is happening. Now if I just want to label this vector A and B for its initial and its terminal point right there. It has position and direction, and it's easy where I put the position at. It's right on 0, 0. I can easily see how far left and right it's moving and how far up and down it's moving. All right, and with that information, okay, it's moving to the right 3, a positive 3, and up a positive. Those are actually labeled by 2, so up a positive 4. What I can say is, well, my vector AB could be labeled as such, or if I want to put it in component form, I could say vector AB is 3, 4. And you need those type of brackets when you're labeling your vectors. It represents vector form, okay, component form. Just those little brackets. They're not squiggly brackets. They're not like that. They're not like this. They're not like this. They're just like this right there. These are the ones we're working with when we're talking about component form of vectors. So you just need to really, all you do is you just find the horizontal change and the vertical change, and it's hard to see this. This is 2, 4, 6, and 8 is why I labeled that a positive 4. Now, if it was going downhill, it would be negative. So you can have in your component form a negative direction. That's okay. All right, so if it is going down, that would be the case. But that's pretty much what we're doing today. I just want you to understand what the little labels mean above. That means vector. Component form, the horizontal and the vertical. Okay, it makes sense because we usually label things X and Y, horizontal and vertical. And finally, if you really are having a hard time with this, I've written out some steps here for you. Okay. You need to know the initial point, you need to know the terminal point. You're just going to count the horizontal and the vertical change, and you're going to label it in component form. Now, we could label either of these vectors, if they're separate examples, as the vector AB or the vector AB, and that would be fine. However, we cannot label them the vector BA. These are not the same thing. This is not the same as BA. All right. The first part right here must be initial, must be the initial. So that is no good, that is no good. The initial point must be the first point in your labeled vector. All right, in component form, this vector on the left would actually be, well, it has a horizontal shift of positive 3 and a vertical shift of positive 7. And like I said, it doesn't matter where the coordinates are. The same vector could be in the second quadrant. As long as it has the same distance and direction, it's still its component, it's labeled as a component vector as 3, 7, no matter where I move it on the paper. All right, same thing here. If I just look, and I decide I want to label this thing in component form, I need to count the horizontal shift. It's going in the positive direction, 6 units, and it's going up, in this case, 4 units. So in component form, it'd be 6, 4. If I want to write it like this, it's vector AB, and that's pretty much everything I want you to know today. Just want you to get familiar with those terms, and we're going to use those vectors to translate. So they're going to give you a shape, and they're going to give you, in component form, 3, 4, and you're going to know that this is going to shift 3 units this way and up 4 units this way, and that's going to be the new position. All right, so we're just going to apply that to what we know about translations. It's just a different dialogue, or a different, what's the word for it? Syntax than what you're used to seeing. So that's everything. It's a real short video, and I hope you know exactly how to label vectors and how to write them in component form.